So we are doing the unit circle. It is 322.17. You'd think it was spring outside, but it's not. Okay, Common Core. F for function, TF for triangular, trigonomic functions, and 1 it is understanding radian measure of angles as the length of an arc on the unit circle. Okay. All right, what is 1 radian? What is the definition of radian? I actually want to show you, okay? What is a radian, okay? Because, you think, okay, well, what the heck is a radian, okay? You ready? Here is what a radian is. It's kind of a cool definition. It really is. I think it's kind of a cool definition. Remember, I'm a big old math loser nerd, but I like it. If the radius is 1, that's 1 and that's 1, okay? If that length is 1, that's length is 1. 1 inch, 1 foot, 1 yard, 1 mile, whatever. That's 1, right? When the arc is also 1. When the arc, and you'd have to adjust it, right? I mean, because all the way around is 3.14, right? So when you adjust, you got to get the angle just right so that you get 1, 1, 1. Then this theta, that angle, is 1 radian. That is the definition of radian, okay? So if this is 1, this is 1. If you can get this arc length just the right size, so it's exactly 1 inch, whatever foot, then the angle, that theta, then is 1 radian. Okay. Yeah. Yeah. Then it'd be 2 radians, which we're going to look at that in here. Okay. So let's do that. Now, first of all, you're ahead of me, which is great that you're ahead of me, Lane, because let's do exactly what Lane said. Okay. So we know this is 0. This is pi. Okay. Now think about pi as a decimal. Okay. 3.14. So if the radius is 1, then if I were to take a piece of string, drape it over this half circle, take it off, straighten it out, and measure it, the length of the string is going to be 3.14 blah blah inches. That's where it comes from, okay? So that now we've got the arc length is actually going to equal the angle, because we're going to say the angle and the arc length are the same, okay? Pi radians is an angle, but it also tells you how long that arc is, okay? Now, we've got 2 pi is all the way around. So again, if I take my string and I wrap it all the way around my circle and then take it off and measure it, it's going to be 6.28 blah blah blah, or twice pi, right? It will be exactly that length, okay? Pi halves, we know pi halves is here. Same thing. If I were to measure this arc length, it's going to be whatever pi halves is, probably about a 1.57, I think. And then 3 pi halves, which is about a 4.7. In fact, I'd like to put those equivalents up there. I need a calculator real quick. All right, so let's get what these decimals are. I want to put the decimals in because it's going to help me today. So, good, I got it. I want clear, quit. So I know this is a 3.14. I know this is a 6.28. And if I go pi divided by 2, I get this to be a 1.57. Right? And times that by 3, and this is a 4.7 right here. Okay, what does this mean? The length from here to here is 1. Let's call it go in inches. Inches, okay? From here to here is 1.57 inches. From here to here is 3.14 inches. All the way to here is 4.7 inches. And all the way around the circle is 6.28 inches, right? Now, where is 1 radian? Just plain old 1. 1's about here. 1 radian's about here. So 1 radian is about approximately equal to about 57 degrees. It's just 180 divided by pi is what 1 radian is, okay? That's 1 radian, okay? 1 radian is about 57 degrees. Now we know pi radians is 180, right? Pi and 180 are equivalents. 1 radian is about 57 degrees, okay? Now 2 then, so if I go 57 times 2, I get 114. So 2 is about here. There's about 2, right? and 2 radians is about 114 degrees. If this is 3.14, then 3 is about there, right? I'm just estimating. If that's 3.14, then 3 is about there. 4 is about here. Okay, 4 is awfully close, right about here. That's 4 radians. 5 is right about there, and of course 6 is right about there. So all I'm showing is that these are arc lengths, right? If I measure from here to here, it's 1 inch, 2 inches, right? Dylan, I'm going to take that from you. Thank you very much. You lucky guy. Now you get to pay attention to me. You are awesome. This is awesome. Okay. Now, so now we have them all around the circle. We won't use these very often. We're going to actually use the pies because the pies are easy to work with, okay? So now, let's go back to example 2. So we've done this. Example 2. Show that the point square root of 3 over 3, square root of 6 over 3 is on the circumference circle. So somewhere around here this point is, right? To show it's on it, we just use its equation. We've got x squared plus y squared equals 1, right? That's the equation of this circle. X squared plus y squared equals 1 squared is the equation of the circle. So I'm going to plug this in for my x value, plug this in for my y value, simplify it, and it better equal 1. If it doesn't equal 1, then it's not on the circle, but it better equal 1. So let's do that. Here's my x and my y value. So I'm going to go square root of 3 over 3 squared plus square root of 6 over 3 squared equals 1. 3/9. You okay with 3/9? Because I squared the square root, squared the 3, plus 6/9. When I add fractions, they have to have a common denominator, which they do. So I get 9/9 equals 1, so yes, this point is somewhere on the inner circle, isn't it? Okay. Example 3. We've done this. Where's my unit circle? We did this yesterday, didn't we? So example 3 is what we did after the test. We're going to draw the unit circle with all the terminal points, right? Everybody has this. All the angles in terms of radians and degrees, radians and degrees, radians and degrees, all the way around. Okay, we did this yesterday, okay? So we got her done. Example 3 is finished, right?
We're going to have to do that on a test.
No, you'll never have to recreate it. You might in college, but what you find is, you see how we did it yesterday, how easy it was? You can recreate it because it all just comes down to these 3 numbers, right? All the way around. And these numbers are easy, right? But these 3 numbers all the way around, okay? Okay. We've done 3. Turn the page. Okay, now, example 4. Find the terminal point for each angle, all right? So pi force. Let's see, pi force is there, right? What's my terminal point? Square root of 2 over 2, comma. So it's just square root of 2 over 2, comma, square root of 2 over 2. That's the terminal point for pi force, right? 7 pi 6. Go ahead, take a look. What do you think 7 pi 6 is? Launder, say it. You're right. Negative square root of 3 over 2, comma. That's it. Easy, everybody agree? Thumbs up? Okay. Look on the circle. Look at the pink. Find 7 pi 6. Thank you. Okay. Now, 14/3 is not on there. But it is. It's just that we went too many times around the circle, okay? So 3/14 is the same as 4 2/3 pi. You okay with what I did? 3 goes into 14, right? 4 times 12, 2. So the answer is 4 2/3 pi. So 14/3 is really 4 2/3, okay? So let's take a journey. 1 pi, 2 pi, 3 pi, 4 pi. 2/3 is right there. I'll do it again over the board, okay? I got to go around the circle 4 2/3 time, right? So, you ready? 2 pi, right? So there's 2 pi, 4 pi, you got it? And then 2/3 is right there. What's my terminal point? Yeah, yeah. So it's going to be internal point is at negative 1/2 and square root of 3 over 2, okay? Negative pi thirds. Now the way you do negative pi thirds is like backing up. If you're in your car and you're looking at your wheel and you back your wheel up this much, you'd be right there, wouldn't you? So instead of going forward pi thirds, just go backwards pi thirds. Same amount, right? Go backwards. You'd be right there, wouldn't you? Does that make sense? Yeah. It's the same amount, but you're rotating backwards, so there's your turning point. Okay? So let me put that on film so you can see it, negative pi thirds. Instead of rotating up pi thirds, it's a backwards rotating up pi thirds. It's a backwards rotation, back pi thirds, but you're right there. My terminal point is 1/2 negative square root of 3 over 2, okay? Now the reference number, okay? The reference number or the reference angle, okay? 7 pi 6. So we'll put angle also. Reference angle or reference number, okay, for the following. 7 pi 6. All right, well, 7 pi 6 is sitting right there, isn't it? If I take a look at my unit circle, isn't it sitting right there? 7 pi 6. Look at your circle, isn't it sitting right there? Right? So to make it easy on yourselves, think about it in terms of degrees, right? That's really a 30-degree angle. Do you agree with that? Okay. So the reference angle is 30 degrees, or in radians, or what's 30 degrees in radians? 30 degrees is equivalent to pi 6. Now, if you're not sure, you can just find it on the circle, right? Here's my 30 degrees, and here's its equivalent, right? Pi 6, right? They're both right. 30 degrees is correct, but let's stick with radians, right? Okay? That's why they mean reference number, because eventually we're going to start calling these numbers, okay? Negative 4 pi thirds. Well, let's see how that works, okay? 4 pi thirds, you ready? Goes all the way around to here, right? You're totally right. Positive 4 pi thirds takes me all the way here, but negative 4 pi thirds would take me all the way to here. So I rotate. I'll show it again on the circle over here so you guys can see it. Okay. So positive 4 pi thirds rotates all the way to here. If I want to go negative 4 pi thirds, and rotate the same amount. Takes me to there. Okay. So the angle's got to be my 2 pi thirds, right? Okay. Yep. Hold that. So that means this is 2 pi thirds, but really the reference angle is this one, which is a 60-degree angle. Have I confused you yet? Okay, because that doesn't make an acute triangle, does it? Does that make an acute triangle? But this, here's my acute triangle. Okay, so again, if I'm right here on the circle, you guys agree? I'm right here on the unit circle. Let's make my triangle. See my triangle? Here's my triangle. What's that angle right there? 6 degrees, right? Now, if we need the number, what's the radian equivalent to 60 degrees? It's up there. So 60 degrees is equivalent to pi thirds, isn't it? We just see this, okay? You don't have to do the conversion, but, 6 degrees, pi thirds are equivalent, okay? Now, what about 4? 4, we got to draw a picture for 4, okay? We got to go back to our reading, okay? So, if I go to 4, this is 3.14, this is 4.7, so 4 is right about there. You okay with that? Remember from our reading? We know that's pi, 3.14, that's 3 pi halves, and I just use my calculator, 3 pi halves divided, right? So 4 is here, right? So I need this angle here, right? I need this angle here. So if I take 4 minus 3.14, I get that angle right there, don't I? What'd you get, Marie?
I got 86.
0.86? 0.86. Okay, there it is. Okay? This is what's really weird. Before I finish, this is what's really weird, okay? Radians are angles. Okay? Radians are angles. This is an angle. It doesn't look like an angle measurement at all, does it? This is an angle, but the angle also refers to the arc length. It's the same as the arc length. But these radians, this pi, go back to my unit circle, okay? This pi 6 is an angle. This pi 4 is an angle. This is an angle, but it also refers to the arc length if the radius is 1. It's going to take a while to get used to it, okay? But they're angles, okay? All right, homework then. Page 408, 24 to 38 even. It's actually pretty easy. And